Hello and good days to everyone. So for today, our group will present about project assignment control system. We are from group 2 section 4 and our lecturer is TS Riza Izwan Ben Samin. So this our group members. So firstly is me, dia is Rifki bin Salihin, matric number DE230064. Next is Edika Fizanah binti AG Satya, matric number AA230035. Next is Muhammad Arif Zuhaikal bin Zulkifli, matric number DE230097. Next, Tay Shiwen, AE230051. And last, Teo Chisan, matric number AE230071. Assalamualaikum warahmatullahi wabarakatuh and good days to everyone. So my name is Dia Isifki bin Salihin. My matric number is DE230064 and I will present about introduction for the group assignment for subject control system. So, firstly, this project aims to develop a system that simulate both open loop and closed loop control, incorporating uh, proportional integral, and also proportional integral derivative controllers. So these controllers will be tuned using two methods, which are the Ziegler-Nichols method and also Simulink PID Auto Tuner. So next point is the primary objective is to analyze the transient response of the system, compare the performance of the different technique, and identify the most effective approach for maintaining system stability, minimizing steady state error, and ensuring optimal performance. This project align with the Sustainable Development Goal 7, which is SDG 7, which emphasize affordable and clean energy. By refining control system, this study contribute to the efficient operation of energy system, reducing waste and optimizing resource use. Next is a second order transfer function is employed to represent the system dynamic characterized by its natural frequency and damping ratio. Understanding the behavior of such system lays the groundwork for designing more complex, higher order system in real world application. Next, for the last point is through this project, we aim to gain insight into control system design, tuning technique, and their practical implication in achieving sustainable and efficient system performance. The finding will also highlight the role of feedback mechanism in enhancing system accuracy and, and robustness.
My name is San, matrix number AE230071. So now I will explain the closed loop for the Ziegler-Nichols method. So this is our closed loop for the method. So this is our desired input graph. We need to get the output like this desired input. So we need to control the value from the PID controller, which is the proportional value. So we can try an error. For example, we can insert the value for 0.24 and then we apply and then we run the circuit. So we know that this output is not our ideal output. So we try an error again. Like example 0.35 and then we apply also and run again the circuit. So this output is like our desired input, so we can assume that our KU value is 0.35 and the PU value is 15 seconds. So now we can calculate our values from the method calculation. So first one, from observation, we know that Ku equal to 0.35 and Pu equal to 15. So we insert a value by using the fixed equation. So the second one, Kp equal to 0.6 Ku, and then we get a Kp value is 0.21. The Ki is equal to 2 Kp over Pu, and then we get the value is 0.02x. The last one is Kd equal to Ku multiplied with Kp over x, and then we get the value is 0.009109. Next, we insert the value into the PID controller and see what output graph appear. So we insert it 0.21 and then 0.02x. The last one is 0.001919, and then we apply and then we OK, and then we run the circuit again. So we can see that the output graph is not the ideal output from the desired input. So we can try an error again. For this one, 1.97 and then 0.36. The D value is 0.29. Then we place it and then run the system. So we can see the graph. Oh, this seems like our ideal output for the closed loop system. So this is the final ideal output for this method for the closed loop system. I will explain the combination of open loop, closed loop, and closed loop for two methods, which is PID autoturn and the Ziegler-Nichols method. So this is our combination for the system. First one is open loop system, second one is PID autoturn, the third one is Ziegler-Nichols method. So we insert the PID autoturn the value. So 0.21552, 0.22746, and the last one is 0.00169, and then we OK. And then we also insert the value for the Ziegler-Nichols method, which is 1.97, 0.36, 0.29, and then we OK. And then we run the circuit, looks the output. Oh, this is our combination for these three system, which is open loop, PID autoturn, and Ziegler-Nichols method. The yellow one is open loop system, the blue one is PID autoturn, the red one is Ziegler-Nichols method. This graph is for the combination for these three systems. That's all from me. Thank you.
Morning, doctor. My name is Dae Matric number is AE2300501. Today, I will explain the open loop by using the PID auto turn method. This is our open loop system. Then we run the using simulation and look at the scope. So this is our open loop system without any controller. I will explain the closed loop by P controller by using the PID auto turn methods. This is our closed loop by the P controller. Then we run the simulation. Then we see that the P controller, as we can see, our proportional value is 0.998. Then we apply it and turn it. Then we can get our graph, our output. Our graph is below the 1. Then we show the parameter. Then we can see our overshoot is between the is on 17.5%. Next, I will explain the closed loop by PI controller by using the PID auto-turn method. This is our closed loop by PI controller. Then we run the simulation. We look at the PI controller. We need to control the proportional value and the integral value. Then we turn it. This is our output for the closed loop by the PI controller. We can see that the graph is above the 1. Then we need to minimize then we can try and error for the response time and the transit behavior. We set that the response time to 1.879, and this one we can set that can 0.738. This graph is overshot, so we need to minimize again. We try and error for the response time to 1.63, and the transit behavior to 0.72. Then we can see that our graph is on the 1 and below the 1. This is our ideal output for the closed loop by PI controller. Besides that, I will explain the closed loop by PID controller using the PID auto-turn method. This is our closed loop by PID controller system. Then we run the simulation. Then we look at the PID controller. You can see that our proportional value is 0.215, integral number is 0.227, and the derivative value is 0.001. Then we can turn it. We can see that our output graph is above the 1. Then we need to, and we can also see the parameters. As we can see, our output is overshot, so we need to minimize that. Then we can try and error for our response time and the transit behavior. Then we can adjust our response time to 1.8 and the transit behavior to 0.73. Then this is our ideal output. Then we can see our overshoot is 1.28%. The combination of the PI, PID controller by using the PID auto-turn method. This is our combination for the PI, PID controller system. Then we can see that our P for the proportional value is 0.998. For the PI controller, our proportional value is 0.25. Integral number is 0.29. Then our PID, Our proportional number is 0.21, integral number is 0.22, and the derivative number is 0.001. Then we run the simulation and see the scope. This is our ideal output for the combination for the PI, and PID controller. The yellow one is for P controller, and the blue one is a PI controller, and the last one is a green orange color for the PID controller. Thank you.
Assalamualaikum, I greet to all. My name is Erika Frizana binti Awang Setia with metric number of AE2300335. So now I will be presenting 6 SDG about our product, which is SDG 7, 9, 13, 6, 11 and 14. So, liquid tank do achieve several sustainable development goals. Firstly, the liquid tank are able to support the transition to a cleaner energy source if it is used to store renewable fuels such as biodiesel and ethanol or manage energy resource. In SDG 7, affordable and clean energy are related to do its help in reducing reliance on fossil fuel and contributing to sustainable energy. Since the liquid tank are mainly used for industrial purpose, it promotes the innovation in storage and transportation, as well as reducing leaks or wastage. Therefore, it contributes in SDG 9, which is industry, innovation and infrastructure. Next, liquid tank do support a proper storage of harmful chemical or fuel, ensure minimal environmental impact, reducing emission and contamination risk. Hence, this contribution in SDG 13, which is climate action. If the liquid tank are used for industrial or agricultural use, it will contribute in SDG 6 for clean water and sanitation because it will ensure efficient resource management, particularly in water-scarce area when the liquid is used for irrigation, sanitation or cleaning. Other than that, it also contribute in SDG 11 for sustainable tank for hazardous or toxic liquid, since it could prevent accident in urban or industrial area, which promotes safer community for safe storage of hazardous material in specialized liquid tanks. Last but not least, by preventing spills or leakage from any hazardous liquid tank, safeguard marine and aquatic ecosystem. This contribute into SDG 14 for life below water. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Zaika bin Zulkifli. My metric number is DA2300097 and I will present about conclusion. Our project is about the characteristic of the open loop and closed loop system. We use the tuning method, for example, Ziegler-Nichols and Simulink PID auto-tune. Okay. Next, from this tuning method, the PID controller tune using Simulink PID Autotune show the best overall performance in this project. Simulink Autotune can achieve a balance of fast response time, minimal overshoot, and zero steady-state error. This ability can be the main point for the best specific second-order system. In conclusion, this project provides us a deeper understanding of the PID controller and tuning method. We can finalize our recommendation about the tuning method and the importance of the proper control selection in control system industry. That's all from me. Thank you.